So last time we were talking about this thing called a discount, rate of discount. What does that mean to you? Tell me in your own words. You pay the interest up front. Okay, so if I want to borrow $50 I want to borrow $50, I would be paying back $50, right? So the way it works is whatever loan amount you borrow is what you will pay back at the end of the period. So let's say that my period is time 1, t equals 1. I will pay back $50, and let's say this is happening at 2%. D equals 2%. What will I come away with? Reason that out with me. Right? So you will pay a charge of 2% times 50. And you will come away with 50 minus 50 times 0.02, which is 0.98 times 50. So last time we had said that D sub n, what does D sub n mean? What does that mean? dn, what is that? I'm talking about this dn on page on the bottom of page 6 we have it, and then we have it again on page 7. Here's dn. What does that mean? dn. Yeah. Yeah, so it's a discount rate. So from what time to what time? Yeah, n minus 1 to n. The discount rate in the period n minus 1 to n. And what was the expression for this dn last time? Tell me in your own words, what does this mean, dn? The discount rate in the nth period, which stretches from time n minus 1 to time n, is given by what expression?
The change over the original.
So change in what?
Change in what the discount rate is.
So what should I be putting up here? What do you mean by change in the discount rate? What does that mean?
It's the change like over the new. So it's like the difference between d of n minus 1 and d of n all over the new value d of n.
No, it's not the change in discount rate. It's the change in accumulation of what is in your account. So it's saying the change in the value of your account, right? So a of n minus a of n minus 1. That's basically the change in your account value, right? Between n minus 1 and n, divided by what? A of n. So divided by the final amount, right? That's the difference between in and dn, right? In, on the other hand, in, which was in minus 1 comma n, was equal to a of n minus a of n minus 1 divided by what?
A of n minus 1.
Right, a of n minus 1. So this is the amount of interest on the top divided by either the final amount in case of discount rate or the initial amount in case of interest rate. You see the difference, right? Okay. So now this is what I want to know. I am at time 0, and at time 2, I want to know how much will I have in my account if D1 is 0.02 and D2 is 0.03. And I'm starting with K dollars. Yeah. Could you work on this and let me know? And then answer the same question for 0, 1, 2. I equals 4% here, and I equals 2% here. And I'm starting with K. How much do I have at the end? So here you go. Morning. What do you say? You don't need your calculator because I'm starting with K, right? So I want to see what you understand. Tell me. Let's do the second one first because it's easier. I'm starting with K dollars at time 0. I want to know what is the accumulated value at time 2. Yeah, so this would be, so to go from here to here, I would times by 1 plus 0.04. Right? That's what I apply to K to get this amount here. So at time 1, I will have K times 1.04. And then to go from here to here, I will apply an interest rate of 2%. So I'm multiplying by 1 plus 0.02, and I'm going to end up with K 1.04 times 1.02. Do you agree with this? Why can I do that? The answer is we do that because we created last time a recursive formula, right? What was that recursive formula? It said that A of n is equal to A of 0 times 1 plus I1 times 1 plus I2 all the way to 1 plus in, but I don't have a 1 plus in because I stop at 1 plus I2. I'm only talking about 2 years. Now can we do the same thing in terms of discount rate? First tell me the recursive formula. So look at this formula right here. Do you remember this from last time? I had cross-multiplied, and I had solved, and then I had solved, so I had gotten this formula that says A of n is equal to A of n minus 1 times 1 minus dn to the negative 1 power. And then I started with A0, which of course is 1. So using this recursive formula, A1 is A0. I'm plugging in 1 here. I'm plugging in 1 into this equation right here. So I get A0 times 1 minus D1 to the negative 1 power. That's A1. But it says that every a of n is equal to the previous a of n minus 1 times 1 minus dn to the minus 1. So using that recursive formula, I get this equation that says a of n is equal to a0, which is 1, times 1 minus d1 to the minus 1, 1 minus d2 to the minus 1, and so forth. So why don't I use that right now, right? Are you following me? So this would be, let's not forget the k, right, over here. So at time 2, I would have a k of 2, which is equal to k times 1 plus I1 times 1 plus I2. I just didn't want to forget this k right here when I was talking about interest rates. So now when I'm talking about discount rates, what will it be? What is a k of 2 in this case? What will it be? Use that recursive formula that we just discussed. That recursive formula says this, right? A of n is equal to a of 0 times 1 minus d1 to the minus 1 and 1 minus d2 to the minus 1. And then I stop because I'm only talking about 2 years. So it's saying in order to go from here to here, you better multiply by 1 minus d1 to the minus 1. And to go from here to here, you better multiply by 1 minus d2 to the minus 1. Does this make sense to you? So AK of 2 is equal to what? K, 1 over 1 minus d1, 1 over 1 minus 0.03. Does that make sense? What is your question? So this shouldn't come as a surprise to you, because didn't we have an equation that said 1 plus I times 1 minus d is always equal to 1? Let me just rehash this, okay? Do you remember that we said last time that if you start at time 0 with L, at time 1, you would be applying this 1 plus I to it. So you would end up with L 1 plus I. So if you are to borrow an amount of L times 1 plus I, now mind you, I'm borrowing it at a discount, so I'm putting it at time 1. In order to find out what you come away with, what do you multiply by? 1 minus d. So I would end up with L 1 plus I 1 minus d if I were to come back with a discount rate of d. Are you following me? Who's lost? Can you let me know? If you are lost, you need to let me know. Yeah.
So in this case, are you assuming I equals D?
I'm not assuming I equals D. I am assuming that I and D have a relationship, and I'm trying to get that relationship. So at interest rate I, if you borrow L today, you are going to pay L times 1 plus I at time 1. Agree? Now I want to create a relationship between I and D. So I'm saying if I were to borrow this amount at some discount rate D, what would that discount rate D be in terms of I? That's what I'm after. So we know that when you take money out at a certain discount rate D, that money is what you pay back at time 1. And my question is, how much should you come away with now? if you're going to pay this amount at discount rate D, but you're going to pay that amount at time 1, what do you come away with right now? So you apply this multiplication by 1 minus D to come back to time 0, right? Because we said if we have K here, if you have K here, the charge will be KD, so you will come away at time 0 with K minus KD. Remember, we said that once before, because if you're paying KD to borrow the money, you're going to pay back K at time 1. What do you come away with now? K minus KD. That's what I'm doing here, see? Except my K is now L1 plus I. So I'm going to come away with this amount times 1 minus D, which will be smaller than that amount, obviously, because you're multiplying by 1 minus the discount rate. So these two better be equal at all times, because that's what you have at time 0, right? So L, we did this last time. I'm just rehashing it. L equals L times 1 plus I times 1 minus D. They have to be equal. Cancel the L's, so you have this relationship that says 1 equals 1 plus I, 1 minus D. So it's saying I and D are not equal, but they are equivalent, meaning that for every I, there will be an equivalent D, and vice versa. So last time we had derived from this equation that D is equal to I over 1 plus I, and that I is equal to D over 1 minus D. So every I has an equivalent D, and every D has an equivalent I. You follow me? And then we had this question last time that said something about 2%. Look over here. Look over here. We did this last class. It says an account is governed by compound interest at annual effective rate 2%. Find an expression for DN, the discount rate, for the nth period between n minus 1 and n. So it's a no-brainer. It's saying I is equal to 2%, find D. Well, we know that there's an equation that links D and I. It's 1 plus I times 1 minus D equals 1, which solves to D equals I over 1 plus I, like I just said on this previous page right here. Right here. So I'm using this D equals I over 1 plus I. And I come up with the D that goes with the I equals 2%. You follow me? And then we went on to say that D is always less than I. There are two ways to see that. I think we talked about one way last time. D is always less than I. You can see that because we talked about this last time right here. It says that D is equal to I over 1 plus I. So I rewrite that with the numerator here, and then this denominator written as 1 over 1 plus I, which is a term which is always less than 1. So basically you're saying D is equal to I times a number which is less than 1, meaning D is always less than I. So did we see our D less than I? Certainly, in our example right here. Do you see what I mean? And then there's another way to show that D is always less than I, and it's much more meaningful. Look at this right here. If I write the expression for IN is equal to the change in your account in the period, in the nth period, divided by A of n minus 1. And this one is equal to the change divided by AN. So isn't this a smaller number, AN minus 1? So wouldn't I always be bigger? Because when you divide by a smaller number, don't you get a larger quotient? So it's clear to see that because I'm dividing by a smaller number here than I am here, this one will be a bigger quotient. So D is less than I. It's obvious to see that DN is less than IN. Get it? What's your question? Yes, sir. Like this? Okay. just a little difficult because once it's zoomed in, it only shows me a little 3x5 portion of my page. So I have to keep, so let me know if you can't see what I'm doing. This we did last time, right? So these two expressions I posted these notes on your blackboard. They're on your blackboard already. So you don't need to keep copying. You can just go print it, okay? You see these two expressions right here? This is key, okay? This is what I used in these examples right here. These examples that I was working on when I said the D1 is 2% and the D2 is 3%, what are you going to have at the end, right? That's what I'm using. So you would put this down. Either put it in here and hit enter or put it on your cheat sheet. You're allowed one little 3x5 index card on your exam. What happened? No, 3x5. Right, Tiny? Okay? So I use this, only I stopped at D2, right? And I stopped at I2 also, right? So these two are really important. Follow me. Let's go to the next page. So the next page talks about a discount function, not to be confused with a discount rate. Totally two different things, okay? So it says here, whenever one can earn interest, a payment of k at t equals 0 is worth more than an identical payment of k payable t time units from now. That's obvious, right? If your mom said to you, honey, you can have $1,000 today, or I can give you $1,000 when you graduate. What's better? For you, not for the mom. What's better? Now is better. Why? Why is it better now? Instant gratification, very cute, but invest it, right? So of course K dollars now is worth more than K dollars in 4 years, right? Because that K dollars now would grow to K 1 plus I1 times 1 plus I2 times 1 plus I3 times 1 plus I4. That $1,000 today could be turned into $2,000 if the market is doing well. Correct? So obviously, the sooner you get your money, the better it is for you. Not for mom, because she's out $1,000 and she could have invested it, right? Anyway, so this is saying that the value of money all depends on the time, obviously, because $1,000 4 years from now would be worth less than $1,000 right now, right? So it says this is because you could invest K today and have a K of T dollars in the future. If the growth of money is proportional to the amount invested, then 1 over A of T invested now will grow to 1 T units in the future. Look at this, okay? At time 0, if I have 1 over A of T, what is A of T? A of T is your accumulation function, which grows $1 to A of T at time T. So if I put in 1 over A of T now, when I apply this accumulation function A of T to it, at time T, I would end up with $1. Do you understand that? Just like the accumulation function for simple interest was what? What was the accumulation function for simple interest? A of T equals what? 1 plus I times T, right? Remember we said that if your interest rate is 5%, in the first year it'll make 5% of the initial amount, and in the next year it'll make 5% of the initial amount. So after t years, it has made I times t, and if you multiply k by 1 plus it, you would get your final amount at time t. So a of t is the accumulation function that grows your money from time 0 to time t. Are you understanding me? Now there's a backwards function too, right? This is called the discount. V of t is equal to 1 over a of t. So this is called the discount function. So let's label it here. The discount function is v of t, which is always equal to 1 over a of t. Follow me? What that allows you to do is take $1 at time t, and when you multiply that dollar by v of t, it will tell you what that is worth today. So it's the opposite process of a of t. A of t takes $1 now and tells you what it has grown to at time t. V of t takes whatever at the end, let's say k at the end, and if you do k times v of t, it will bring it back to the present moment. So this multiplication by v of t, which is called the discount factor, gives you the present value. So the present value of 500, let me write it here. The present value of 500 at time 3, if I have $500 at time 3, what is it worth today? Answer, multiply by v of 3. So if I'm going back, I multiply by v of 3. This will give me the present value, meaning the value right now, 500 v of 3. And this v of 3 is going to be different whether you're talking about simple interest or compound interest or simple discount or compound discount. It'll change. So it's a different function depending on what kind of interest or discount you're discussing. But what you need to get out of this discussion right now is that there is a function called the discount function, v of t, which gives you the present value of some amount. Here I have 500. I could have k, I could have l. So the present value would be l times v of t. Follow me? What's your question? Not to be confused with discount rate. That's different. Okay? This is the discount function. Okay. So it's saying here that ax of t equals 1. So here, this is just saying that if you have x now at time t, you will have ax of t. And the way you got to it is by going a of t. You grow it by some accumulation function, a of t. So it's saying that the amount at time t is equal to xa of t. So if we set that amount equal to 1, suppose ax of t is 1, then this x would be multiplied by 1 v of t, which is 1 over a of t. I'm applying a function v of t to it, which is the reciprocal of a of t. So if I have 1 at time t, I would have 1 v of t right now, or 1 over a of t right now. Are you following me? Just take the value you have at time t and multiply by v of t. Finished. That gives you the present value. Let's do the next problem. Suppose that the growth of money over the next 5 years is governed by simple interest at 8%. Remember that with simple interest, you are better off closing and reopening your account at the beginning of each year, since the effective interest rate decreases each period. This is why we created the compounding of interest, where the effective interest rate remains constant. How much would you have to invest now to have a balance of $100,000 at the end of 3 years? So it's saying how much now at time 0 so that you have $100,000 at time 3 years. And it's saying please use simple interest. So can you tell me what is the accumulation function for simple interest at 8% simple interest? What is the accumulation function? Hello? Little a of t is equal to 1 plus 0.08 what? T, right. 1 plus IT is the accumulation function for simple interest. Therefore, what is the discount function for simple interest? V of t equals 1 divided by 1 plus 0.08 t. All I have done is take the reciprocal, right? So, if I'm going back, I want the present value. I would take this 100,000 and multiply by V of t. So my answer is, actually, you know what? Please let me not write the 100,000 here, because I'm applying a factor of only V of t to it. So this would be 100,000 times V of t at time 0. I have taken my 100,000 and multiplied by V of t to get the present value of that 100,000. So my answer is 100,000 divided by 1 plus 0.08 t, because all I'm saying is this. V of t is 1 over 1 plus 0.08 t. So t is 3 for me in this example. So 100,000, yes, 100,000, 1 plus 0.08 times 3. Can you get me an answer, please? What do you get? 100,000 over 1.24, basically. What do you have? Shouldn't it be less than 100,000? 80,000 how much? 80,645.16. That's the present value of 100,000 when I'm using simple interest, 8%. Are you with me, folks? It says when you multiply a value k by the discount function v of t, you get the present value at time t equals 0. Let's do the next problem. You will invest money in 2 years to obtain 23,000 5 years from now. Okay? So at time 5, the value would be 23,000. The problem is you're not investing that money now. You're investing that money in 2 years. How much should you invest at t equals 2? Assume simple interest I equals 5%. Question is, how much should I put in at time 2 so that I have 23,000 at time 5? Any ideas? What is the accumulation function for simple interest? This you should know, right? We just used it. A of t equals what? 1 plus, right, I can't say 1.05, right? Right, 1 plus 0.05 times t, right? So I dare not say 1.05 t. It's 1 plus just the 0.05 times t, right? Okay, so v of t equals what? 1 over, exactly right, 1 over 1 plus 0.05 times t. So now I ask you, how much money should I have at time 2 to invest, which will turn into 23,000 at time 5? What do you think? Yes?
We go back all the way to 0 and then solve for 2 going forward.
Yes, you should, but why should you do that? He says, take the present value of 23,000 all the way to here, bring it to time 0, and then grow it to time 2. And my question is, sounds great, but why? Yes?
In case we want to know how much we want to invest right now.
Okay, but is there something wrong with going 23,000 V of 3?
No, I mean that in case we want to know how much we want to invest right now.
Makes sense. Makes sense, but I'm asking, do I have to go that route? Is there something wrong with saying 23,000 V of 3?
No, we don't need to.
Pardon?
We don't need to.
Can I do that or no?
We don't need to go.
You don't need to go back? What do you guys think?
Are you allowed to go to these 2?
I'm asking you.
I don't know.
I'm asking you, why can I not go 23,000 V of 3? I thought that V of 3 brought you back, right? Multiplying by V of 3 brings you backwards. So I'm asking you, why are you doing what you're doing? Coming back to 0 and then growing it to time 2. Why can I not do 23,000 V of 3? What's wrong with that?
Is that because we're then assuming that time 2 is time 0 and then we throw off the interest because we invested something at 0,
Yeah.
grew it to 2, then it goes to 5?
Okay. Yes. You're so on target. Okay. So the answer to this question is, if you are using simple interest, which I am right now, right? Simple interest, it's really important to distinguish between simple and compound. If you are using simple interest, you can only do this problem by bringing this 23 back to time 0 and then growing it to time 2 using V of 5. Apply V of 5, which will bring it to 0, and then apply A of 2, which will bring it up to 2. Now the question is, what's wrong with saying 23,000 V of 3? What's wrong with that? Yeah.
Is that because the interest rate will be decreased after the
Exactly right. Simple interest has a monotonically decreasing effective interest rate, right? So not only does it matter how many years you are discounting, but it matters where on the timeline those 3 years are. Because bringing back from time 3 to time 0 is different than bringing back from time 5 to time 2. Because that interval of 3 years, it matters whether that interval is at the beginning from 0 to 3, or if that interval is later on from time 2 to 5. Why? Because this is simple interest, and as we know already, simple interest has a monotonically decreasing effective interest rate. So if you wait to time 2 to invest your money, to pull out at time 5, you would have missed the first 2 years of the highest interest rate. Follow me? So you would have to put more money in at time 2 to acquire $23,000 than you would have to put at time 0 to take out at time 3. Even though this is 3 years, and this would also be 3 years from time 0 to time 3. But you would need to put in more money at time 2 than you would at time 0, even though the interval is exactly 3 years. How do you like that? Right? So I want you to find me the answer to this question. I want to know, how much should I invest at time 2 so that I have $23,000 at time 5? So can I say 23,000 times V of 5? That will bring me back to time 0. And then to that amount, I will apply A of 2. Because A of t, listen to this carefully, is an accumulation function that tells you what you will have at time t for $1 invested at time 0. A of t cannot be applied beginning at time 2. You follow what I'm saying? So get me an answer to this, would you? So I'm going to divide by 1 plus 0.05 times 5, and then I'm going to multiply by 1 plus 0.05 times 2, which gives me what? Can you get me an answer, please? 20,240 is what you will invest, at t equals 2 to have 23,000 at t equals 5. Right? So you better not be saying, you better not say 23,000 V of 3. That would be wrong. You better not say that. This would give you an answer of 20,000, and that would be the wrong answer. Any questions? Okay. What if this were compound interest? That's actually on page 9A. Can we skip to that because I want to make that point before we go away? let's skip to page 9A for a minute. What if this were compound interest?
Well, wouldn't the only difference be that A of t would be 1 plus I to the t instead of 1 plus it?
A of t is equal to 1 plus I to the t. Okay, any other differences? So I'm saying, again, my question is this. How much should I invest at time 2 to have 23,000 at time 5? Yes. Right. For this scenario, you don't have to go back to time 0 and then forward to time 2. Why not? IN is constant for compound interest. Right? Well, that means that I don't have to do this. Don't have to do 23,000 times V of 5 times A of 2, and you'll see why in a minute. V of 5 is 1 over A of 5. 1 plus I to the 5. I'm dividing, right? Times 1 plus I to the 2. Because all this cancels and I get 23,000 over 1 plus I to the 3rd power. Anyway, because in this case, for compound interest, 1 plus I squared divided by 1 plus I to the 5 is 1 over 1 plus I cubed. So it's the same as saying 23,000 V of 3, where this is just 23,000 V to the 3, where V is 1 over 1 plus I. Right? Are you following me? So now I don't have to do this. You don't have to first take it back to 0 and then grow it to time 2. You can just discount 3 years directly by saying 23,000 divided by 1 plus I to the 3rd power. This is in the case of compound interest. Let me go back to simple interest and see why this wouldn't work there, right? Compound interest. In the case of simple interest, see here, this is 1 plus I and this is 1 plus I, so they would cancel. But in the other case, they wouldn't cancel. Let's go back and put that in. So this and this don't cancel, you see. You cannot say 1 plus 5 times 0.05 and 1 plus 2 times 0.05 and cancel and say this is equal to 23,000 over 1 plus 3.05. That's not true, because 1 plus 0.10 over 1 plus 0.25, you can't cancel here. But in the case of compound interest, you can. You see the difference? Okay. Yes, sir. For simple interest?
Yeah, the answer 2240 as a second year. So I got 276 at the end of the
I'm sorry, I don't understand. I didn't understand what you said. The 2240 is what you would need at time 2 to grow to 23,000.
If I put that in a function, 1 plus 0.5 times 3 at the end of the 5th year, I got 23.
You can never use the A of t function if you are starting at time 2. That A of t function The A of t accumulation function assumes that you are starting at time 0 and ending at time t. You can never use the A of t function starting at time 2 because it's not valid for starting at time 2. A of t is defined as the accumulation function given $1 at time 0. What is its value at time t? You may not start, you cannot start at time 2. Get it? Okay, I guess I have to stop here.